Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily lead code problem, and the problem's name is Spiral Matrix Part 4th. So the problem statement goes like this. You will be given two integers m and n, which will represent dimensions of a matrix. Okay, and you will also be given the head of a linked list of integers. Okay, so then you have to generate this m cross n matrix that contains the integers of the linked list presented in a spiral order starting from the top left of the matrix. Okay, so we will try to understand this statement with help of an example. Okay, so let's take the very first one, and let's take the inputs also. So these are the inputs. So see, the head of the linked list will be this particular one that will be given to you, or this will be the linked list whose head will be given to you. Okay, and then you have to start from the very first node, which is the head, and go till the very last node, and keep on filling the row in a clockwise direction. Okay, starting from the top left. Okay, so this is top and this is left. Okay, so starting from the top left corner you will be doing a clockwise thing. Okay, and as when you are exhausted with the number of elements in the linked list and you are falling short of some elements which are needed to be filled in this matrix, then you will substitute those values by minus ones. Okay, so this is what we have to do. Okay, if there are any remaining empty spaces, fill them with minus one. Okay, and then we have to return the given matrix that we have just formed, this m cross n matrix. Okay, so we have to return this. So this is what we have to do in the problem statement. Now before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the number of rows and columns will be of order 10 raised to power 5, and e okay, and the multiplication of both of them will also be of the same order. Okay, and the number of, or you can say in a way, total number of cells. Okay, so the number of nodes in the list is in the range from 1 to m cross n, which is equal to the number of cells both inclusive. Okay, and the last constraint is that the node values will be ranging from 0 to 1000. Okay, so since the number of cells is of order 10 raised to power 5, so if we think of something in order of 10 raised to power 5 or equal to the number of cell, then we should not be having any trouble of getting our solution accepted. Okay, and that much time complexity will be sufficient to get us past all the test cases. Okay, so let's see how we can think of solving this. So a very straightforward approach that is coming to my mind after reading the problem statement is that we can run a simulation, uh, just like doing what we are told to do. Okay, so we will be starting from the very top left corner and then we will be going down a spiral way. Okay, and as when we are we have exhausted the values of this matrix, then we will be using minus ones. Okay, now the whole things comes down to the implementation of this simulation. Okay, and for that I will be taking the board code to the board. Basically what we will be doing here is I will be also telling you in a brief overview, then we will be proceeding to the implementation. So as I have already marked two of the pointers, top and left. Okay, and then let's mark two others, then right. Okay, and this one will be the bottom. So initially top will be set to the 0th uh, row, and since there are m rows and it's a zero based indexing we are following in the matrix, so it will be m minus 1. Okay, bottom will be equal to initially m minus 1, and similar will be the case for left, since left and right are representing the columns. Okay, so left will be initially 0 and there are n columns and 0 based indexing, therefore n minus 1 will be initial value of right. Okay, now let's see how we can follow that spiral order. Okay, for that let me erase some path that we have already drawn up here. Okay, and let's start from the very beginning. So the first direction and the start point will be the top left cell. Okay, and then till when you will fix the basically row value will be equal to the top, and you will be changing your column values from left to right. Okay, one by one. Okay, like this. Okay, and along doing these things you will be having one another variable. Okay, which will be current will basically be pointing to the, or you can say current node will be pointing to the node in the linked list that we are want whose value we are wanting to insert in the current cell being explored. So we were exploring the first, so its value was inserted, then we moved the current node to the next node, current pointer basically you can say, or the reference of that node. Okay, now the current node is pointing to 0, then we inserted 0 and it will continue. Okay, so now this direction is done. Now comes the direction of this way. Okay, from along the right and right column and from top to bottom. But you see we have already covered this one, so we should be increasing our top. So top will now point to this particular one. Okay, so from this value of top to here and along the right column we will be covering these two. Okay, in this direction. Okay, and we will keep filling the values. Okay, now your current node will be here and then it will come here 1 and 7. Now once you are done with it, you see this right column is entirely filled, so there is no use of keeping our right pointer here. We should be moving it towards this direction. Okay, so that next time you are filling in this direction, so your right boundary will be helping us to do so. Okay, so then next directions comes the bottom right to left direction. Okay, now your row will be fixed. Okay, here in this particular case your column was fixed. Okay, which was equal to right, by the way, at that time. Now this time your row will be fixed, which will be equal to the bottom. Okay, and then once you are have done filling up all these values, your this particular row is done. You need not to make your bottom pointer to point here any longer, so you will be moving your bottom pointer to up direction. Okay, or top direction. So now both of the pointers top and bottom will be pointing to this particular row. Okay, and now what you will be doing is you will be repeating the whole process. Okay, from left to right again. So this time left to right again you will be doing the whole traversal thing. Okay, and then once you have done it, then you will basically be saying that okay, we have already filled this column and let's shift our left towards the center. And this is how these four variables top, bottom, right and left will be helping us to you know uh, change our directions and doing the filling in the correct spiral clockwise direction. Okay, spiral order you can say. So without confusing you any further, if you are not very much clear with the implementation till now, let's bring the code to the board and then everything will be clear to you. Okay, although you must have got an idea how this implementation will be done, but anyways, let's dive into the details. So this is the implementation, and let's remove this toolbar. So let's start. So since I already told you we would be needing these four variables, left, right, top and bottom, and their initial values I already told you that left and right are helping to move along the columns. So 0 to n minus 1, since matrix was of m cross n size, m rows and n columns. Okay, and since it was a zero based indexing, so n minus 1. So here also for rows top to bottom m minus 1. Okay, 0 to m minus 1. Okay, and then we will be declaring the matrix that we will be returning as the return type of this particular function. Okay, of m cross n size obviously. And then as I talked about that we would be needing a pointer to the current node, which will be starting from the head and going till the very end of the linked list. So this is that pointer current. And then we are also counting the number of cells that we have visited. Okay, so it will help us to keep count that we are done with filling the matrix or not. Okay, so that's that being said, now let's move down further. Then you will do the actual filling of the values in the matrix. Okay, so till either of these conditions runs out, you will be you know continuing your filling. Okay, uh, either your current is not equal to null. Basically current number of nodes will never exceed, so number of cells is a sufficient condition. Okay, although I have written both of these. So anyways, then what we will be doing is we will be moving from left to right. Okay, for left to right we are fixing the row here. Okay, fix row to top. Okay, so row will be always fixed as you can see here, and then this column variable will be varying. It will be varying from left to right, and this is safe is just a check that we are we have not exhausted every entry that is to be made, or all the cells are filled or not. Okay, so what it does is, let me show you quickly. So it just confirms that the left and right pointer should be either left should be either less than right or equal to it. Okay, this should not be the condition that your left is here and your right is here, they have already passed each other. Okay, in that case it indicates that you have to stop the operation. Okay, so this is just a safety check. Okay, just to keep in check those four pointer variables. Okay, and similar will be the case for top and bottom. Obviously they can be equal or bottom can be larger, but top can never be larger than the bottom. Then in that case you have to stop the whole process of filling. Okay, so this is that check only. And then initially you will be saying that we will be trying to fill -1, but if we are having some uh, values left in the linked list that are not being used in filling process, then we will say let's update our value and move the current pointer to the next node. Okay, then we will be simply filling the row. So you are doing this direction this time. Okay, and then as I told you already, in that case your top will be done, so this entire row is filled. So let's move our top to one step below. Okay, So that's why increasing the top. Okay, then comes the other direction, which is from top to bottom along right direction. Okay, so you will be doing this direction along the right column. So this time the column number will be fixed to right. Okay, and the row will be varying from top to bottom. Okay, and this is that same call is safe, and then you are doing pretty much same thing here also. Okay, and then once you are done, as I already told you, this entire right column will be filled, so you should be moving your right towards the left. Okay, so we are doing that only, and in the next part you are moving from left right to left along the bottom. Okay, so this way you are doing. Okay, and it's pretty much the same logic. Okay, and each time you are increasing the number of cells that you have filled. Okay, and this time since the bottom row will be filled, so you should be moving your bottom up, bottom pointer, so we are doing that here. And then this is you are moving from bottom to top. Okay, along the left direction, along the left column you can say. Okay, so now you are doing this direction along the bottom, along the left, sorry. Okay, and the same logic will be applied here, but this time since earlier the row was fixed to bottom, now this time the column will be fixed to left, and the row will be varying from bottom to top, since we are going from uh, bottom to top direction. Okay, and then this whole thing will be repeating, and the spiral will continue till when you have filled all the cells. Okay, and basically when you will be done with it, you will be having your matrix, which is the required matrix. Okay, as your answer, and you will be simply returning it. Okay, so this was the whole logic, just some using some variables, and keeping in mind the directions that we have to take and updating them. So this was the whole implementation and logic. And if we talk about the complexities here, time complexity wise, it's order of m cross n, because you see we are all only visiting each cell a finite number of times, so that will be the complexity. And phase complexity wise, it will be order of 1 if you are not considering the result array, the matrix 2D array that you are using to return the result. And if you want to consider it, then it will be m cross n obviously. Okay, so it's totally up to you. So if you are not considering, then constant space, as we are using some 3 or 4 variables here and there, and then not using any extra space. And if you are considering the extra space that is used up for returning the result, then it's m cross n. Okay, so these are the complexities. And if you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills. And keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.